Hello, welcome to SM Tech World. Today is the day 24 of July LeetCode challenge. So today we are going to solve today's problem. The today's problem is all path from source to target. So basically, if you read the problem statement, it's saying that you will be given one two-dimensional array. You can think that as a graph, and it says it will be a directed and acyclic graph. That means there should not be any cycle in the graph, and all the edge will be directed. So you can traverse from one node to another node using directed edge only. So it will not be an undirected edge. Okay. So these are the two assumptions, and they also give some note like this. The nodes range will be 2 to 15, and you can print different paths in any order, but you should keep the order of nodes inside one path. Okay. So let's solve this using Java today. So let's discuss our algorithm first, then we are going to solve it. So I just copy the same example here. So it's saying that how we can identify the number of nodes. So you need to calculate the size or the length of the input array, right? In this case, we can see the length of the input array is 4. That means we will have 4 nodes. So 0, 1, 2, 3, and the last node will be 3. Obviously, the last node will be your target node, right? And the first you will always start from 0 itself. Okay. So it will be start from 0. So this will be our starting point, right? And this will be end. Okay. So let us draw the edges for this graph, then we will try to solve it. So probably if you just represent that matrix for better understanding. So it's for 0, then 1, just a second. So since we have 4 node, so it will like this, right? So you can see that it's pointing to 1, 2. Again for 1 we have only 3. Again for 2 we have only 3, and 3 is a blank. Okay, the last node. So how we can build the graph using this input graph? So I can see, okay, from 0 I can go to 1, and we can go to 2 also. Okay, so there is 2 edge from 0. Again from 1 we have only 1 edge to 3, right? So it will look like this. Again from 2 we can go to 3 only, right? So yeah, so this is how our graph will look like, right? So if you see this visually, there can be 2 paths. So I can start from 0 and I need to reach 3. 3 is the end, right? I can go like this 0, 1, 3. So that can be one path, and I can go like this 0, 2, and 3. Okay, so that can be other option. So we need to find all the possible options, right? So let's solve it. So if you think naively, how we can solve it? So basically we can apply DFS algorithm here. So DFS is nothing but depth first search, right? So we can use depth first search traversal algorithm. So what I will do, so suppose I am starting from 0, right? So so from 0 I can, according to DFS algorithm, I will go to till depth. Here in this case our depth is 3. So whenever we will reach to our depth or our target node, we need to backtrack, right? And we need to backtrack and we need to find that is there any other possible path or not, right? So let's see how the DFS will work. So I will start from 0. Okay, so from 0 I can see I can go in 2 ways, right? Either in 1 or either 2. So probably I am taking this path. Okay, so my path is 0, 1. Now from 1 I have only one option. I can go to 3 only. Okay, I will come here 3, and I will see that okay, 3 is my last node. I don't need to find anything. So I already found my one path. Okay, so then I will go back. I will come back to here. Okay, and I will check, is there any option to go? No. I will say again there is no option to go, right? So I will come back here. Okay, then again I will from 0 I can find, okay, I have option here, right? I can go to 2. Again from 2 I can go to 3. Okay, so there can be 2 paths, 0, 1, 3 and 0, 2, 3. So let's write it in Java today, and I will explain it further after writing the logic. So this is the main logic we are going to apply here. So we are just going to use the basic DFS algorithm here to traverse. Okay, so let's start. So at first what I need to do, we need to return one list of integer, right? So let us define that first. So probably name it as R, and it should be a new array list. Okay, and yeah, that's fine. Now what I need to do after that, so so you can see that we need to track the path, right? So inside this will be a list, right? So I need to maintain a list for all the possible path, and then I need to return all the combination of the list, right? So let me declare another list also for the same, to keep tracking all the paths. So let me take his name is that path only, and again I am going to take array list here. Okay, now what I need to do, and once we are done with that, we are going to return our result array, right, or R. Okay, so result list. And now what we need to do, we need to create one DFS method using which we are going to traverse. Okay, so in this DFS method, what I need to pass, I need to pass my input graph, obviously I need to pass my current path also, and again I need to pass my result also, and apart from that I am going to pass my index, right, from where we are going to traverse, right. Initially we will start from 0, right, so we're going to pass that also. So let's define our DFS function now. It can be a private method and we are not returning anything. It can be a void return type, and let me name it as DFS only. And what are our input is graph, right, 2-dimensional array. Let's define those also like this. Now we are going to also pass integer list also, so let's add it here also. Then we are going to pass this result, add that also, and at the end we are going to pass the index also, right, index from where we are going to start. Okay, now what I need to do, so let's write our stopping condition. So here, what is our stopping condition here? Our stopping condition is whenever we will reach our end node, then I am going to stop going from depth, right. We don't need to go further, or we don't need to run our logic again and again for that. So let's write that stopping condition first. So here we are tracking that using that index variable. So whenever my if index equals to my graph dot length -1, that means we reach to our last index, right. What I need to do then, so here my result array or R, I am going to add my current path. Okay, so it will look like this. I will explain it once again after completing the code. Just complete it, let me complete it first. Okay, and we are just going to add my path, right, whatever my path is, we are going to add it in our list. Okay, and let me define it as integer only, since we are storing integer value. Okay, now what I need to do, we need to stop it, right. So since it is void, we can just like return like this. Okay, so that will be our stopping condition. Now let's write our code for actual DFS or DFS traversal. So how we can start, so this is our graph array look like, right. So it's a 2-dimensional. This is how it looks. So from 0, I will start from 0 and I will check from where we can go, either 1 or 2, right. So I need to pick those value, right. For that I need to write one for loop. So sorry, it will be here only. Yeah. So int n, and I am going to traverse graph particular index, right. Since we are starting from 0, we will, for the fast iteration we are considering this portion, right, or this array. Okay, so now I am here. So what I will do, I will pick the first one and add it in our path, right. So let's add that in our path itself. So path dot add in, so that index value. And what I need to do, we need to call our DFS function once again, right. So I added it 1. Now I will come here and check. Okay, from 1 I can go to 3, right. So let's write this portion, this logic. Okay, so for that again I am calling DFS, right. So kind of recursion. So again for DFS we are passing graph, then we are passing path. Here we already path, so here path will look like 0, then 1. Okay, path, then we are going to pass the result also, and then in this case index will become 1 here, right. So n will be our index, and once we are done with that, we need to backtrack, right. So suppose whenever we reach here, we need to backtrack and check is there any path exists, right. So to backpath that, to backtracking that thing, we need to just return that. We need to remove the last element from the path, right, to backtrack. So path dot remove, so it should be path dot size -1. Okay, so this is for just backtracking. Okay, and so once we are done, I think we are enough. Let's run it. That's the whole logic we need, I think. Let's run it and check. Yeah, it's giving me some compile error. Let me take those first. So it's R. It will be array list, and okay, initially we need to add path also. So it will be path dot add. So initial my path will be 0, right? Since we are starting from 0. So there are a couple of spelling mistakes at first, the return and this one, right, integer. And we also add this path. So we need to start from the 0 path. So we are going to we added this, right, initially, right? Okay, let's run our code once again and check whether it's running or not. Yeah, you can see it's giving me expected answer. Let's submit it also. After that, I'm going to explain the whole flow once again and check whether it's accepted or not. Yeah, I think it's accepted. So let's discuss what we are doing here, okay, once again, and the code flow, right, how the code is working. So we took this result array first, whatever we are going to return, and we took one initial path, right? So since we are starting from 0, right, so for 0 we took one initial path, okay. So probably let me give example here also. So initially I take one path and I added 0, right? Since always I am starting from 0, I added this, okay. Then I called my DFS function, okay. Now what I do here, I am checking, okay, 0 is not my end index, right? So we can move further, so we don't need to stop. So again, after moving further, what we are doing here, after checking this edge condition, the stopping condition, we are going through each and every nodes for that particular index, right? So I will start from 0, right? And okay, I will find there is couple of nodes in 0, right, 1 and 2. So again, I am going to add, so at first I will start from 1 and I am going to put that 1 in the existing path. So existing it was 0, added 1 also, right? And then again I am calling DFS, right? In this case my index will become 1. So again I will start from here, okay, and I will find, okay, it's my 3, right? So I will going to add 3 here, okay. So this will be my current path, right? And my result list is still empty, right? So again, whenever we will pass index 3, and I will see, okay, it's my last index, right? We don't need to add anything. We are just going to add that path in our result array. That's done. We already done with that, right? So after that, my list will contain the first path 0, 1, 3, right? Then again I will come back. So once we are done with this, we are removing that path, right? So we are removing that path. So I am going to remove 3 from my path, okay, and check, okay, from 1 can we go into another node? No. Then again I am going to remove that, okay. Now again I will come back to here and I will see, okay, we have 2, right? So I will pick that 2 and I am going to check for 2. Yeah, again I can go from 2 I can go to 3 from 2, right? So I am going to add 3 here. Again I am going to this condition will be successful, right? When I am going to pass index 3, again I will find, okay, 3 is my end node, last node, so we don't need to go further, right? So I am going to add it in our existing path and we are going to return that, okay. I think that's pretty much for this video. If you still have any doubt, please let me know in the comment section. I think hope you will be able to learn something from this video. If you like this video, please subscribe to our channel. Thanks for watching. Bye bye.